Hello, let's evaluate the summation equal to summation k equal to 1 to infinity 4k whole cube plus 3 by 4k factorial, right? Let's start this. I equal to summation k equal to 1 to infinity, where this will be 4k whole cube by 4k factorial plus 3 by 4k factorial. As you can see, the first term, this can be written as 4k whole square into 4k, right? By this can be written as 4k into 4k minus 1 factorial. Thus 4k will go off and the remaining part is this plus 3 by 4k factorial. Okay. As you can see, in the denominator of the first part, you can see there is 4k minus 1, right? So let's do one thing. Let's add minus 1 plus 1 by 4k minus 1 factorial plus 3 by 4k factorial. So this will be k equal to 1 to infinity 4k whole square minus 1 square by 4k minus 1 factorial plus 1 by 4k minus 1 factorial plus 3 by 4k factorial, right? Then I is summation k equal to 1 to infinity. This can be written as 4k minus 1 into 4k plus 1, right? Then 4k plus 1 by, this can be written as 4k minus 2 factorial. Then 4k minus 1 will go off, right? 4k minus 2 factorial. Then this will be, second term will be 4k minus 1 factorial plus 3 by 4k factorial. So now you can see in the denominator of the first part is 4k minus 2. So summation k equal to 1 to infinity. Now what will you do? 4k minus 2. As there is a plus 1 in the denominator, you must add plus 3 by 4k minus 2 whole factorial plus 1 by 4k minus 1 factorial plus 3 by 4k factorial. So I is summation k equal to 1 to infinity. This can be written as 4k minus 2 by 4k minus 2 factorial plus 3 by 4k minus 2 factorial plus 1 by 4k minus 1 factorial plus 3 by 4k factorial. Fine. The first term can be written as summation k equal to 1 to infinity. This can be written as, how will you write is 4k 4k minus 2 1 by 4k minus 3 factorial, right? The denominator part can be written as 4k minus 2 into 4k minus 3 factorial. So this one is 3 by 4k minus 2 factorial plus 1 by minus 1 factorial plus 3 by 4k factorial. So let's do one thing. In the numerator there is 1, right, for 2 terms, and 3 is for 2 terms. So let's do one thing. Let's split it as summation k equal to 1 to infinity 1 by 4k minus 3 factorial plus 1 by 4k minus 2 factorial plus 1 by 4k minus 1 factorial plus 1 by 4k factorial. So then what are the remaining terms here? As there are 3 by 4k minus 2, here there is only 1 by 4k minus 2 factorial, right? So the remaining thing here it is twice of 1 by 4k minus 2 factorial plus 1 by 4k factorial is remaining. As you can see, there is a 2 factor there, then it will combine here in the first term, it will give 3. So uh, let's rearrange these terms. Right? Then as you can see, so I mean, let's expand for k equal to 1 and see for the first case. Let us assume this as I1, this as I2. So let's deal with I1 case. If I equal to 1, then the first term I1 will be 1 by 4 minus 3, 1 factorial. 4 minus 2, 2 factorial, minus 4 minus 1, 3 factorial, plus 1 by 4 factorial. Plus when k equal to 2, it will be 8 minus 3, 5 factorial, plus 8 minus 2, 6 factorial, plus 8 minus 1, 7 factorial, plus 8 factorial, plus and so on. As you can see here, how does it look like? It looks like 1 by, right, 1 by k factorial, summation k equal to 1 to infinity, right? That is I1 is summation k equal to 1 to infinity 1 by k factorial. What about the second term, I2 part? I2 is summation k to 1 to infinity 1 by 4k minus 2 factorial plus 1 by 4k factorial. So let's expand and see. When k equal to 1, this will be 4 minus 2, 2 factorial plus 1 by 4 factorial. When you k equal to 2, it will be 8 minus 2, 6 plus 1 by 8 factorial and plus so on. As you can see here, the factorials are even terms, right? So it can be written as 1 by 2k factorial and summation k starts from 1 to infinity, right? So I is I1 plus I2, which is I is summation k equal to 1 to infinity 1 by k factorial plus, sorry, I1 plus 2 I2, right? There is a 2 term here, 2 times of I2. I2 is summation k equal to 1 to infinity 1 by 2k factorial. As you can see, the first term here, I1 is e power n is 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on, right? So our summation starts from 1, right? So this will be our I1, that is e power 1 equal to 1 plus I1, that is I1 equal to e power 1 is e minus 1, I1 is e power I minus 1. What about the I2? I2 looks like 1 by 2 factor, 1 by 2k factorial, which is cos h1. Uh, you can check it once. Cos h1, the formula for it is e power 1 plus e power minus 1 by 2, right? Which is 1 by 2 into, sorry, 1 plus, which is 1 plus 1 by 1 factorial plus 1 by 2 factorial plus and so on. For this case, it will be 1 minus 1 by 1 factorial plus 1 by 2 factorial, 3 factorial plus and so on. So here this will be 1 by 2 into, as you can see, 1 by 1 factorial goes here, it will be 1 by 3 factorial. Well, the only remaining terms are here, this case here it is 1 plus 1, 2 plus 1 by 2 factorial plus 1 by 2 factorial, 2 by 2 factorial plus 2 by 4 factorial plus and so on. This will be, if you take the 2 common in the numerator, it will be 1 plus 1 by 2 factorial plus 1 by 4 factorial and plus so on. Right? Our case is cos h1 equal to 1 plus 1 by 2 factorial plus 1 by 4 factorial plus and so on. So our case starts from 1 by 2 factorial, right? I2 is, this is the case, that is cos h1 equal to 1 plus I2, right? That is I2 is cos h1 minus 1. So I is I1 plus 2 I2. That is I1 is E minus 1, right? Plus 2 times I2 is cos h1 minus 1. So let's expand this. E plus 2 cos h1, there is minus 1 minus 2, which is minus 3. So I is E plus 2 cos h1 minus 3. The final result is summation k equal to 1 to infinity 4k whole cube by plus 3 by 4k whole factorial equal to E plus 2 cos h1 minus 3. This is the final solution.